Hey guys, so in this video we're going to be looking at assigning R and S configuration to a chiral center. So we're going to learn how to assign R and S configuration for a chiral center. First of all, let's go over what is a chiral center, or a chiral carbon in specific. It's a tetrahedral carbon which is connected to 4 different substituents. So you have here like a chlorine, a hydrogen, a bromine, a CH3. You must have 4 different substituents. They cannot be similar. So chlorine, and here carbon, the first attachment is different, and bromine and hydrogen. So therefore this one will be chiral carbon. And sometimes you can actually have a carbon that has a CH3 here and has here a CH2 CH3, and then it has a OH and H, for example. This carbon has a carbon here as a first attachment to 3 hydrogens, a carbon to 2 hydrogens, and a carbon, so the whole thing is different. Your first attachment here is oxygen and this is hydrogen, so as well this is a chiral carbon. So any chiral carbon can be distinguished on paper by the R and S configuration. So chiral carbon is a stereogenic center, or a stereocenter, where if you switch any 2 substituents, that will give you a new stereoisomer. From there we can just learn how to assign R and S to make life easy. As we said, how to assign R and S, we have this. So what we learn here, that we will be looking at priorities to assign R and S based on the atomic number of each substituent. We will assign it 1 to 4, which is highest to lowest. Then you will just do rotation if it's clockwise or counterclockwise. If it's clockwise, it's going to be R, counterclockwise is going to be S. The most important rule is your lowest priority must be pointing away from you. You can think about it this way and then apply the rules here based on that. So we have 3 general cases. Number 1, when the rule applies and you have the one that has the lowest priority pointing away from you, which is the normal case. Assign priorities now. Bromine on this carbon has got the highest priority, highest atomic number. It's followed by oxygen, and then carbon, and then hydrogen. So hydrogen, which has got of course the lowest priority, is pointing away from me. That's perfect. This is what I need. So therefore this is the normal case. Then you will just go 1, 2, 3. You're going now this way, and that's R clockwise. So this is the normal case. If it's clockwise, it's R, which is the case here. If it's counterclockwise, it's S. Fine. The second case is when your lowest priority is a wedge. Do everything the same as before first. Bromine has got the highest priority, oxygen, carbon, and then hydrogen. Assign it normally. If you're going this way, you will think it's R, but then you're going to switch it to S. And if you're going this way, you think it's S, but then you're going to switch it to R. This is because you imagine yourself standing behind the molecule where H will be pointing away from you. And instead of imagining, not to confuse yourself, do it this way. Your lowest priority is a wedge. Assign it as usual, and then whatever you get, switch it. So if you get R, switch it to S. If you get S, switch it to R. In this case, we have 1, 2, 3, 4. You're going clockwise. You would think it would be R, but no. It's going to be S. The third case is when you have the lowest priority in plane. You're still doing the same scenario based on atomic number. 1, the bromine has got the highest priority, then OH, then carbon, then hydrogen. So you're gonna go 1, 2, 3, but hang on. Is this the one that has away from you or towards you its line? Therefore, first of all, you will draw this as a Newman projection between this carbon and the hydrogen as a substituent. You're going to be standing here, your carbon will be the front and the H will be the back. Stand here, this is the carbon. So for Newman projection, if you know, you are having a top view. You look in here, this is the carbon and it's behind it connected to a hydrogen. So you see a carbon, up you see a bromine. You are inside here, looking down this axis, the carbon-hydrogen axis. You see in the plane an OH on your left-hand side. You see something pointing towards you or out of the plane, which is a CH3 on your right-hand side. Remember, you are here looking down this way. You see on your right a CH3, on your left you see OH, which is in the page. You draw it here. Now you have a Newman projection. Now we're looking down the carbon-hydrogen axis. Now the one that has the lowest purity is pointing away from you. Then 1, 2, 3. Now assign it normally because you now have made your Newman projection. It's going to be S. You don't switch anything here. If you have a molecule like this, you look for the chiral carbon, which is the asymmetric carbon. It has 4 different substituents attached to it: OH, CH3, and a propyl group. The H here has got the lowest purity. This is the normal case. Assign it wherever you get. It's the thing you're looking for. OH is number 1. A carbon to an ethyl group is number 2. A carbon to 3 hydrogens is number 3. You're going counterclockwise, then it's S. In this case, you have 2 different chiral carbons. Assign each one separately. In this case, you have the one that has the lowest purity pointing away from you. 1, 2, 3. You're going counterclockwise, it's S. On this carbon, you have 1, and you have the lowest purity pointing away from you, so it's normal case. So first of all, look for the lowest purity. It's pointing away from you. Perfect. It's the normal case. So 1, 2, 3. 1, 2, 3, going this way, so this is R. And this is the normal case. The last example, you have the lowest purity in plane. Here we go. You put the numbers as usual, 1, 2, 3. Don't panic. Draw yourself looking down this axis between this carbon and this hydrogen. Draw a Newman projection here. What do you see? On your right hand side now, this is the Y Newman projection. It's like a Y-shaped Newman projection. On your right hand side, you have a chlorine. In the page on the left hand side, you have a CH3. Down in plane, you have a propyl group. Fine, then 1, 2, 3, you're going clockwise, this is R. So remember, the first thing you do, you assign purities based on atomic number. If you're number 4, the lowest purity, pointing away from you on a dash, perfect. Normal case, clockwise, R, counterclockwise, S. If your number 4, the lowest purity, is on a wedge, then whatever you assign, switch. If your number 4 is on plane, in plane, on a line, then draw a Newman projection, look down the axis that has the H, and imagine if it's pointing away from you. And whatever you assign, you assign. Here, whatever you assign, you switch for this one. But here, whatever you assign, clockwise R, counterclockwise S. For the third case, clockwise R, counterclockwise S. While for the middle case, when it's on a wedge, you switch it. I hope that was helpful, and thanks for watching, and good luck.